Now we are going to start a discussion of job shop scheduling. The term scheduling specifies when labor, equipment, and facilities are needed to produce a product. And the term job shop scheduling means the production planning and control techniques used to sequence and prioritize. There are two things: to sequence and prioritize production quantities across operations in a job shop. So sequence of operations is of course shown by the routing sheet, but the real challenge actually in a job shop is this thing, the prioritization of the jobs, because we have the same resources on which different orders are waiting to be processed. So job shop scheduling is also known as shop floor control. It is also called production control and sometimes production activity control. Generally speaking, there are two approaches to scheduling in a job shop, and these two approaches are also actually applicable to project scaling, but they have different names. One is called forward scaling. It assumes that material procurement and operation scaling for a component start when the order is received. Forward scaling is used to calculate how long it will take to complete a task. This method is used to decide the earliest delivery date of a product. So you should note it down and we will see what it means. So forward scaling helps us determine the earliest earliest delivery date. A due date is something different we will discuss, but it is used to determine the earliest delivery date of a product or for an order. In contrast, the backward scaling, in backward scaling, last operation on the routing is scheduled first. As the name implies, that the last operation on the routing sheet is scheduled first and is scheduled for completion at the due date. Previous operations are scheduled back from the last operation. This schedules items to be available as needed. Backward scheduling is used to determine the latest start time for an order. So forward scheduling helps us to determine the earliest delivery date, and backward scaling helps us to determine the latest start time for an order. So you should note down the 2 points. Work in process inventory in backward scaling is relatively less as compared to forward scaling. But because there is little slack time in the system, customer service may suffer. So again, the slack time is a term from project scaling. This is the cushion that you have in your plan, the extra time that you have in your plan. So that is called slack time. So generally speaking, you are having more slack time in forward scaling than you are having in backward scaling. So this is a simple example of forward and backward scaling. So we receive an order, say at date 0, and we know that there is a certain time. So let's assume that the numbers show the dates or the days. So material is ordered on day 0 and we expect it to receive it here. So that is the lead time for purchasing. And then this much is the lead time or the operation time for first operation, then this much is for the second operation, and this much is for the third operation. And we expect to finish the order, complete the production of this lot for this order on date 7. In the case of backward scaling, now you could see that this is the due date when we have to deliver the order. So first we plan the last operation, that is the third operation, and we will see the end date for that, and we schedule back. And the start date of the operation 3 is actually the ending date of operation 2. So we schedule back and decide the starting date of operation 2, and that is the end date of operation 1, and we schedule back to decide the start date of operation one, and similarly for material order. Of course, this time is an estimate and depends upon the historical data, and and this is scaled back. So you could see that in forward scaling, this is the estimated delivery date. And once again, this is the earliest delivery date. Similarly, in the case of backward scaling, this is the latest we can start the order to be processed. So this is the latest start date, you can call it. And this much, in the case of forward scaling, we call it slack. Now, this is not mandatory that you start this order in forward scaling at this date. This is all the schedule that you are making. So, for example, this is around 3 days. So you can actually delay the order for this much time. And you might notice that this time that I have highlighted here should be approximately equal to this time. So this is called the earliest start or earliest start date, and this is called earliest finish date or earliest finish, and this is the latest start, and this is the latest finish. Now, practically, of course, you can actually backward schedule, say from here backward to have some slack in the system, and you can actually forward schedule, say something from here to avoid the buildup of work in process inventory. But this is the plan that we have made. This is the schedule that we have made. Yes, slack is also called float, and slack time is also called float time. So, of course, you can easily see that the chart that we have made is a Gantt chart. So we are having the time periods mentioned at the top, and we are showing the activities horizontally. Now, in this plan, we have made a big assumption. And can anybody figure out what was the assumption? We are assuming here that right after we have received the material, we can immediately start the first operation. And once the first operation ends, we can start the second operation. And once the second operation ends, we start the third one. And same is something we assumed in the backward scaling as well. Actually, of course, the plan will be executed in this direction. So these operations are to be performed on certain machines. And in the job shop, we have general purpose machines. They are used for almost every order. So the assumption that we have taken is technically it is called infinite loading or infinite loading. We assume that the workstations on which operation 1, 2, and 3 are done have capacity available when required. The machines are available, machines are free, and you can perform the operations when you require. This might be true in some cases, but this is not always true. We did not consider the existence of other shop orders competing for capacity at these work centers. So we assume infinite capacity will be available. So we can perform the operation whenever we require. But practically we are having finite loading. And actually I will re-emphasize that infinite loading is not something theoretical. In some cases we can have infinite capacity. Of course, mathematically it is not infinite, but the capacity is much greater than what is required. So in that case, we call it infinite loading. But finite loading assumes that there is defined limit to available capacity at any workstation. So if there is not enough capacity available at a workstation because of other shop orders, the order has to be scheduled in a different time period. So we will see how is that done, but this is just an example to show that in the same for the same example that we saw, this is where we received the order, but machine was not available. So this much is the wait time someone rightly mentioned. So this is the queue time. And then here, after a couple of days, first operation can start. And after first operation, this much is the queuing time. And then second and third operation will be performed. And here we are assuming that the third machine will be available when second operation has ended. And similarly, you could see for the backward scaling as well. So this is a big assumption that we had taken. So in this case, we are assuming finite loading. In the previous, we were having infinite loading. So I hope that is clear. So how we can make a schedule? Let's take a simple example that we are having a product that comprises two parts A and B. A requires two operations, operation 10 and operation 20, and they take 5 and 3 days respectively. And part B requires only one operation, and that is operation 10, and it requires 10 days. And we are assuming that we are having two different machines available for operation A. So that is assumption in this case, and we will see if that assumption does not hold what we can do. But in this case, we are assuming that. So a company has an order of 50 brand X to be delivered on day 100. Draw a backward schedule based on the following. Only one machine is assigned to each operation. So you could see that operation 10 is required for both part A and B, and we are assuming that we are having two machines available for this operation. But we will see if that is not the case, what we can do. The factory works one 8-hour shift 5 days a week. The parts move in one lot of 100. And this point is also very important. And we will come back to it. That what is meant by this, that the parts move in a certain quantity. I tell you the terminology that we are making the part in a quantity of 50. So that is called production lot. Or sometimes it is called production batch as well. And we are moving the parts in the quantity of 50 as well. So that is called transfer batch. So production batch and transfer batch. So we'll see that why this is important. So this is a simple example, but just to give you an idea, we will first solve for backward scaling, and then we will see what will change if we are using forward scaling. So I'm not going to make a Gantt chart here, but just to give you a rough idea how we will actually make the plan. So we have to deliver this part on day 100. On day 100. So the total time you could notice is around, considering the parallel activities as well. So that is around 15 days. So we can draw the time at intervals of 5, so 90, 5, 90, and 85. So we are backward scaling. So first we will plan for assembly X. So that requires 5 days. So that we start its production on day 95 so that it is available on day 100. Now you could see from this simple product structure that A and B can be processed in parallel. And we are assuming that a separate machine is available for A and B as well. So A requires two operations, 20 and 10, and operation uh, 10 will be performed first and then operation 20. And operation 20 requires 3 days. So for part A, it requires around 3 days. So operation 20 requires 3 days. So that is operation 20. This was assembly X. And operation 10 requires 5 days. So something over day 87, up to day 87. So this will be operation 10. That should complete at around day 87. Similarly, the assembly B requires one operation, that is operation 10. And that can be performed in parallel because we assume that we have two machines available. And it requires 10 days, so it will go right back to day 85 so that the product is available on day 95. So that will be operation 10 for, for part B, and this was for part A. And just for clarity, this should be day 87. So this required 5 days, and this was 3 days. And this is 10 days. This is 5 so that you are not confused about my rough timeline. So the latest start time for part B, the latest start is day 85. Latest start for operation 10 for part A is day 87. Latest finish is day 92. And similarly, that is the latest start for operation 20, and the latest finish for operation 20 is day 95. And that is actually the latest start for assembly X. Now that is the backward schedule. Now what would change if we were making a forward schedule? Now everything will remain the same. I mean, the figure will look very similar, but the time values will change. So only the time values will change. For that, we will have to assume, of course, what is the earliest start date. So depending upon that, we can make similar calculations. For example, just for the sake of illustration, we assume that the earliest start is, say, uh, day 70. Then simply this will become day 70, and this will become 75, and of course this will become 80, and this will become 85. So you could change the values for part A and B as well. But for example, if we are going for the forward scaling and we are having the earliest start as day 70, then we can have the earliest finish on day 85. So this will be actually then day 70, and this will be the earliest finish for part B, that will be day 80. Similarly, this will be 72, if I'm right. This should be 77. This should be 80, and this should be 85. So just cross check, I hope it is correct. So in that way, we can make the forward schedule as well.